Yes, so we have already gone through all the types of transformation. Now we want to take the WASC question and solve. This is the West Africa examination, which is called the WASC, and we're going to take 2005, and we see how we can apply all what we've learned so far. So I read the questions. They say, using a scale of 2 centimeters to 2 units on both axes. I'll just paraphrase the question for you, but the major details of the questions are on the board, but I'll paraphrase this for you so you understand what I'm saying here. We said that using, the question says, using a scale of 2 centimeters to 2 units on both axes, draw accurately and in their exact position the letters T, A, N. These letters, we are on the question paper, so it's like it was drawn and it is pasted on your question paper. You're supposed to replicate this on your own answer booklet. So you are given a fresh graph paper. So the question is asking you to draw exactly, first of all, you draw the axis 2 centimeters to 2 units. You know how to do that already. It's 2, 4, 6, 8, 2, 4, 6, 8 on the x-axis. So on your own graph paper provided for you, now you insert on that graph paper, as you see these letters on this question paper, you insert them in their exact position. That's the demand of the question. You say in their exact position the letters T-A-N as they are on the question. So you now take this and just translate it on your own answer booklet in your own graph paper. So let's assume that I have already drawn this TAN on my own graph paper as you see it on this board now. So it's like the first part of the question has been solved for you already. I have already drawn the axis for you and inserted the letters in their exact position. So now we go to the proper question. It says, now after doing that, you now look at the letters individually and apply the techniques we have already learned there, the techniques of transformation involving rotation, translation, and even reflection and all through. So you check, the first one says N, the letter N, capital N, is supposed to be reflected in the line on the is reflected in the line under a reflection. You are going to reflect letter N under a reflection in the line y equals to 1. So remember when we said that the type of reflection in the line y equals 1, in this case is y equals 1. So it was where we said reflection in the line y equals a constant, and remember we said it is the y-axis that is affected in that case. So that's what happens there. So what you do now for the n, so we need to collect the coordinate for n. So you must be also ready to understand, to get the fact how to actually take the coordinates from the diagram. So I read the points there. This tip of the T was drawn from this coordinates 2 and 3. So this is 2, 3. Must be able to read that. And this is 3, 6. This is 6. And here it is 1, 6. Must be able to get that. And A is 4, 3. That's the first thing you have to know. First, this is 6, 3. This is 6, 3. So this tip of N was drawn by 7, 3. And this was drawn by 9, 3. And this part was drawn by 9, 6. And this is drawn by 7, 6. So now, and here you drawn here by 5, 6. And this intersection line for the transmission line for A, or if you were to read the question paper, you put your ruler and try to read. You read it right down here. It will fall on 4.2, 4.2, 4. It goes with 4 there, but it read 4.2 down here. So you must be able to read it on your graph paper. Just to assume now that it is. So it is. So now we have, this was supposed to be read here. This is 4.2. This is the second point there, and 4. So this one becomes 4.2, 4. So that is this transmission line. That transmission line, if I get a point, then I can just draw that line straight. It goes. So I don't need to get the other, look for the other point, because it's just a transmission line that goes. So now I'll be able to read all this. You must be able to get the reverse. You know, in the previous questions, you were given the coordinates and you draw the graph. You plot the graph. But now the structures are drawn for you on the graph paper, and you should be able to do the reverse. Look at the structure and take out the coordinates that we are used to draw these letters. So those are the coordinates. So the x coordinate comes first before the y. Understand that? So here this is 2, 3, and this is 1, 6. This is 3, 6. That's how I got out of that. So the first question says translate letter n. So I go for the coordinate of n. N is 9, 6, and we have 9, 3, and there is 7, 6, and you have 7, 3. So there is 7, 3. So I've taken the coordinate of n. This is n. N contains this 7, 6, 9, 6, 7, 3, 9, 6. So that's n over there. Now the question says reflect the n in the line y equals 1. So that is the formula for y equals 1. Remember the x coordinate here, the y coordinate, and the key in this question is the y, which is 1. So I go with that. This is going to be x. The 9 will not change, but the 2 and the k is 1. That's 1 there. And the x, the y now is 6. So this guy goes. This is going to be 9 comma 2 minus 6. So you have finally 9 comma minus 4. I get that. So this other guy here is 9 comma 2 into 1 minus 3. So this gives you 9 comma 2 minus 3. So final position becomes 9 comma minus 1. So you go, just do the same here. This is 7 comma 2 into 1 minus 6. So this equals to 7 comma 2 minus 6. So you have 7 comma minus 4. I come back here. This is 7 comma 2 into 1 minus 3. So we go, this is 7 comma 2 minus 3. So here we have 7 comma minus 1. So I've got all the points. Remember, all these things you will not be giving marks for that. It's just for you to go through them rapidly. So let's go first and plot. We are supposed to plot. It says draw. You are going to draw. It is a picture that gives you the answer. So we go, this is 9 comma minus 4. So I go 9. This is 9 here and minus 4. Minus 4 is down there. This is 9 comma minus 4. And I go with 9 comma minus 1. This is 9 minus 1 somewhere there. You have 7 minus, this is 7 minus 1. 7 minus 1 somewhere here. And 7 minus 4 somewhere here. 7 minus 4 here. So you have got the leg of the n. This is n and that is n. Now, so you got to be careful how to draw that transition line for n. You go back to the question. The question says reflection, and in reflection, if I am supposed to reflect n on that n is standing there, and I'm supposed to reflect it, I will have the n appearing this way. N must go this way, not this way. If I put the n this way, it means I've translated it. Now this is reflection because the question says reflection. So you watch out how you draw that line. If you draw the line this way, it means you have reflected, you have translated the n. But the question says reflect. So it is, this transmission line must come this way, not the other way. Because if you draw it this way, it means you translated the n. You did not reflect the n. But the question says reflect. So reflection, when you reflect this corner, this angle must reflect this. This leg, reflect this leg. That is reflection. So we have reflected the n. So we go back to the next question. There A, say under a translation by the vector 3 minus 9. So we go for A is having coordinates. A is 4, 3, 4, comma 3. And we have 6, 3. And there is 5, 6. And there is 4.2, comma 4. We have 4.2, comma 4. And this A is translated using the vector. The vector is 3 minus 9. So we have 4. I use column form of that vector, so translate. Remember the formula for translation is object plus translation vector, which is the shift vector over there. The shift vector is 3 minus 9. So it's 3 minus 9. So this guy becomes 7 minus 6. Yep. So this other guy here is also 6, 3. We add it to the vector. The vector is 3 minus 9. So this gives me 9 minus 6. Now I come back to this other guy. This is 5, 6, and it is translated by the vector 3 minus 9. We add this plus this is 8 minus 3 here, and the last guy here it's 4.2, comma 4. So I translate it. This is 3 minus 9. This gives you 7.2, comma minus 5. So I plot. I'm plotting 7 minus 6. So this is 7 minus 6. This is 7 minus 6. So I go down here. So I have 7 minus 6 somewhere there. And I have 9 minus 6. This is 9 minus 6 somewhere there. So I have 8 minus 3. This is 8. And you have minus 3. Minus 3 somewhere there. So that's it here. And you now use the ruler. You try to draw the leg of the A so that you know that it has been translated. So this is translated. This is translated. So you have the two legs of A. Now your target is to get the transmission line somewhere. That transmission line is 7.2, comma minus 5. This is 7, 7.1, 7.2. comma, minus 5. This is minus 5, minus 5, 7.2, comma, minus 5. So it's 7.2. This is 7. This is 0.1, 0.2, 7.2, comma, minus 5, minus 5. So this is where the transmission line must be. So I've got the A. The A has been translated. Translation, the size of the object will not change. It's just the position that will change. We have established that long time. This is A was taken to that point. So it has, I've translated it to there. But X, the N was reflected. Watch out for this question. Very technical. Now we go to the last question. T. It's a T under. We take the coordinate for T. It's a T is now anti-clockwise 90 degrees. So we take the coordinate of T. T is 1,6, and you have 2,3, and you have the next one there is 3,6. So you say T. T, we want to translate T. We want to rotate T. So T is rotated. Rotation, T is rotated 90 degrees. So watch out. In 90 degrees, what is the anti-clockwise? Anti-clockwise, we said, is minus y, comma, x. That was the formula for anti-clockwise. So we now look at it. This is minus 6, comma, y, 1. And here is minus 3, comma, 1. Minus 3, comma, 1. And here it is minus 6, comma, 3. Minus 6, comma, 3. It's a plot. So anti-clockwise is minus 6 and 1. This is minus 6, comma, 1. This is 1 somewhere here. So, and minus 3, comma, this is minus 3, comma, 1. This is minus 3, comma, 1. So we get this 1 here, minus 3 somewhere there. And you have the next guy here. It's minus 6, comma, 3. So it goes minus 6, comma, 3. Minus 6, comma, 3. This is minus 6 and 3. And this was minus 6, minus 3, comma, 1, minus 3, comma, minus 6, comma, so we have 3 and 6. But let me read the point again. Is 2, 3, and the other one is 3 and 6. Yes, correct. And we have 1 and 6. So it's minus 6, 1. I've got that. Minus 6, 1. And I have minus 6, 3, then I got that, minus 6, 3, then I have minus 3, 2, is minus 3, 2. So here, I come back with minus 3, 2, this is minus 3, then 2, somewhere here. So I have the 3 points, so I draw there, and I bring it down here. So you can see that the T has been rotated 90 degrees. It's like it was pushed, the T was pushed here, so it was standing that way, and I push it anti-clockwise, it dropped that way. So that is anti-clockwise according to the question, and this is reflected there, and this other guy is translated. So and this, we have done all the 3 types. So now I want to use magnify the T, so that you also see how the enlargement can come. So far, because of space, we can just end that question there, because the question ends at T. I want to add on the question so that I can magnify this T, and we'll do all 4 reflection altogether. So that is what you're going to expect from the 2005. Watch out for this question. This is the reverse, where you are given the object, the coordinate, and you plot the structures. But this case, it is the structure that is given, and you're asked to plot for yourself. So this is what is called the transformation of vectors by structures. So we have done 2005. So watch out now. I have more questions to come. So keep watching. Yes, so we're back. Welcome back. We want to continue with more examples, and as we move with your exam questions, we look at November 2000. We have just done June 2005, and you saw how the structures were analyzed for you. Now we have another type of question here, which is November 2009, and this one is a complex question because it's going to embed 2 or 3 topics together. So we are going to see in this question, we are going to have a vector, which is going to be superposed by construction, and by extension you also have measuration inside. So this is a complex question, so I want you to watch out how we're going to do that. So it reads, because of time, I'll be paraphrasing the question. The question says it is a quadrilateral. It's using a scale of 2 centimeters to 2 units on both axes. It says draw the two perpendicular axes OX and OY with intervals minus 10 on the x-axis, minus 10 less than equals to x and less than equals to 10, that is on the x-axis, and minus 10 less than equals to y and less than equals to 10. So now it tells you that your x-axis starts with minus 10 and goes to plus 10 on the x-axis, and y-axis also minus 10 to 10. So because of space, I'm just trying to keep this space for me to do the work over there, so watch out for what I'm saying. So I've already answered the first part of the question, say using a scale of 2 centimeters to 2 units on the x-axis, Now draw two perpendicular axes OX and OY with the intervals as stated below, and see now draw that triangle, that quadrilateral is 4,6. So we're going to draw it first. We have to plot that. This is 4,6. That is A. Yeah, so watch out if the question says and vertices and their coordinate, you have to make sure the vertex is the letter and the coordinate is the numbers there, so 4 and 6. So because of the ink, I want to leave that space. The space is so tight, so I want to just be writing the vertices and leaving out the coordinate. When the exam, you try as much to write the vertices and the coordinate as we go. So B is 4, 6, 6. That is 6, 6. That is 6, 6. That is B, and you have 2, 2, that is 2, 2, this is C, and you have 8, 2, so 8, 2, this is D. So you can now draw, it says it's a 4-sided polygon, that is a quadrilateral, so it says draw it. So this guy it looks like a trapezium. So you have constructed that, you have drawn that already, and now he says, now using after drawing this, he says now you draw under the enlargement with scale factor -1. So we're going to draw A1, B1, C1, D1 under an enlargement with scale factor -1. So the second question is scale factor. The scale factor is equals to -1. So if I have A1 must be, I said, and it is from the question says scale factor A1 from the origin. So we are going to enlarge this trapezium using a scale factor -1 and from the origin. Remember I said when you are enlarging from the origin, you just multiply all the coordinates by the scale factor. In this case, our scale factor is this. So now we want to look at how we multiply all the scale factor by the coordinates. So we move with that one. The first one is multiply -1 by all the coordinates. So you have -4, -6, because 4 multiplied by -1 is that. So you have B1 is also -6, -6, and we'll have C1 is -2, -2, and you have D1 is -8, -2. So you say draw. We need to draw. So we can draw. So I can extend this line now here because I need more coordinate in this arena. So I have -6, I have -8, then -10 in that order. So now I have -4, -6. This is -4, -6. That is here. This is A1. And we have -6, -6. This is -6, -6. So you have that -6, -6. This is B1. And you have -2, -2. This is -2, -2. This is C1. And you have -8, -2. -8 is D1. So you go with that. This is here. So you see a small trick play here. You are expecting it to be bigger because the world is enlarged, but this enlargement, the scale factor was -1. So it's not going to be bigger than the object because the scale factor is just unity. When it's unity, it is, because it's minus, it's just going to change the position of the object, but it's not going to increase the object because the scale factor is a unit, and unit times anything is the same thing. It's just like multiplying 1 by a number. It's still the same number. So the scale factor is 1. It's just changing the position of it. So we go to the second question. The second question says, now we want to look at the, it says construct it says find the area of ABC. That's the second question. It says find the area of ABC. So we want to find the area of ABC. That's Roman figure 2. The area of ABC, you know that is area is half B1 plus B2 times the height. So this is half into B1 is this distance, B to this, it is 4 to 6 is 2. So you have 2 plus this is 2 to 8 is 6. That's 6. And multiply by the height. The height of this guy here, it's 2 to 4, 2 to 6, that's 4. So you have 4 somewhere there. So you have, this is 8, 8 times 2, that's 16. So if you want to put 16 meters square, let's say the x-axis was in meters. So we have 16 meters square. How I got that is 2 into this is 2. This plus this is 8. 8 times 2 is 16. So I've done the next question is the area of that stuff. So that is mensuration. Watch out, I told you that this question involves mensuration, involves vector, and involves construction. So we'll see very soon. The next one is construct a locus L1 of point equidistant from C and D. It says construct a locus of point equidistant from D, C, and D. You see here we are supposed to construct a locus of point equidistant from C and D. You see equidistance, locus L1 is equidistance from C and D. So the locus is from 2 points. 2 points is, the 2 points are C and D. So in this case you require to bring your construction materials. So let me take my ruler. So we will look at your protractor and your compass. So I have my own compass here. You can use your own in the text box. And we say construction, when it is 2 letters, we are bisecting the distance between the 2 letters. So it's between C and D. So let me come and this was C and D was 8 and that's D. This should have been D. So this is C, D. So we are bisecting that line joining C and D. So you can watch out for the 2. It's the same. So we have the 2 there. So I can just, we know how to bisect from construction. We are standing here, we bisect from this is the line we are trying to bisect. So I open to a convenient radius. I go there. Maybe I go down again to cut. Then I use the same point here. Then I also cut that. Maybe I bisect it down the other way there. I can bisect the other way there. Yeah, so I have to be careful because of the frictional force. So I have bisected the distance joining the 2 of them there. So it says equidistance from A, C, and D. So the 2 lines there, I connect the 2 together. So we'll have the 2 of them joining. So I'll move with this there to this. I connect it with my ruler. So this intersection of these arcs. So I have, you see, locus of point equidistance from C and D. So C and D, I bisected the line, the distance between C and D using the construction material. So it's L1, I call it. So I go to question number 2. Question number 2, it says locus, construct a locus L2 of point equidistance from CD, and so Roman 3 is CD and D and DB. So these are line segments, so you know that already. For line segment, you look for the locus joint of 2 line segments. You look for the common letter. The common letter is D. So we are standing at D and we bisect the angle formed at D because the 2 lines are meeting at a point D. See, it is common to both of them. So I'll stand at D. That is, I bisect that angle. The angle D is what we are trying to bisect. So I go back there. You also use your own protractor. So I'm coming to bisect this angle. It's B, DB, and CD. That's what is here. DB and CD. So I bisect. You stand here. You try to bisect this angle formed by these 2. So you can use that. So this is small arc is cut here. I cut a small arc somewhere there. Then I move to this arc. I cut. Then I move to this arc too. I cut. So what I did is to stand here, cut small arcs and small arcs. Then I move there and cut, and move there and cut. So now that is how that locus is achieved. So we achieve the locus by that exercise. So we now use your ruler and connect the points here. So watch out here. It's a highly complex question, but I know you can follow me as I'm moving. This is, I use my ruler and bisect that angle. I've already got the arc, so I bisect that angle. So that angle, this locus is L2. So watch out for what I'm doing here. I have already, let me make the rectangle, the trapezium cool for you. So you see, it's properly. So now I have done locus L2. So this is D. So C. So we go with the question. So watch out for this question. It's a highly technical question, but I know you can follow. Now it says, now next question, it says locate the point P, the intersection of L1 and L2. So we want to locate the point P, the intersection of L1 and L2. So I'll use another. This is P. It's locate the point P, the intersection of L1 and L2. So the two of them intersect there. So I've located the P. It's a whole question. When you answer that, you there already. So the next question says, yeah, and with P as center and PD as radius, construct a locus L3. You see, with P as center and PD as radius, it's a construct locus L3. So we are looking at the same construction material. So I have my compass, blackboard compass. So you see, with P as center and PD as radius, construct locus L3. So the center is here. Then I open the compass to a convenient radius. So you open the compass there. Then I open it to that D. That is P as center and PD as radius. So the D is the radius. Now I say construct locus L3. So you construct a locus L3 through that D. So you go with it straight. So it goes through that here. So that's locus L3. So locus L3 has come like that. So this is locus L3. It's passing through that D. So let's say it's passing through the D from there. So that is the locus L3. So we label it, we call it locus L3 in that case. So let's say it's locus L3. It's a circle that goes around there. And the question says again, since it is locus L3, it says now locate P as center and PD as radius, construct locus L3. And so locate the point Q, the intersection of L1 and L2 above AB, the intersection of L1 and L2 above L3 above. So we are going to locate Roman 4, L1 and L3. We call it Q. You say locate the point Q. Yeah, locate the point Q, the intersection of L1 and L3 above AB. So this is L1 and this is L3. So they met at a point. That point is Q. So here they met here. This is L1 and L3. So they met at a point Q. So locate the point Q, the intersection of L1 and L3. So this is L1. You constructed that before, and this is L3. That is the circle. That is the circle you wanted to draw. So now where L3 meets with that L1, that point is Q. That is the question. Now the next question says, yes, and measure QPD. Measure QPD. So watch out. You say measure QPD. The angle in the middle is the owner of the letter in the middle is the owner of the angle. So watch out for that. So we have. So I get that. Let me just keep my protractor somewhere there. Then I come back to the question. Now it says measure Roman 5 if you like. This is measure. It's a QPD. So the letter in the middle is the owner of the angle. So we are measuring QPD. So let's say we want to actually measure it based upon our protractor here. So this is it. So it's QPD. I'm going to ensure that my line is just there. That's a line going through there. So I'm measuring QPD. So we started here from 0. I can use the bottom scale, somewhere here. So that is somewhere around 115. This is just at a point. So watch what I did here. This is I'm trying to like measure this. This is QPD. So I'm measuring that arc. I measure that angle there. So that's what I'm measuring here. So I must ensure that this line is on this here. So this center is just there. So that is where I place the P there. So that's the line on that straight. It is on that line straight. So it's there. So now I can go and read here. So let's say from the bottom here, I'll go right there, right there, right there. So that's exactly on 120. So I got this angle as 120. So 120 degrees from my protractor from there. So I've measured this angle to be 120 and say measure that. That's what we have measured so far. And we go to the next question. It says calculate the length of that arc. So if you have measured here as 120, now you say calculate the length of that arc. So remember what you have done. The length of an arc is theta over 360 times 2 pi r. And in that question, he gave you r as 3.142. So you now have the theta as 120, and this is 360, and you have times 2 times 3.142 times the radius. So it's now left to the students to come and measure the radius. So if you do it carefully, you now use your ruler to measure the radius. The radius of this length, that is from here, you measure from here, that is from P to D. You measure from P to D. So you'll be able to get the radius. So if you do it from in your own, using your own ruler, let's say you have a point, I have 0.15 here. So let's say you have a 5 centimeter in your own ruler there. Let's say 5 centimeter. So you have 5 centimeters from here. That's the rule here. So you punch this. This will give you the answer, and that will give you the length of that arc in centimeters because you are using a centimeter ruler. So now you have seen that this question was a combination of 3 topics put together. You did the vector, and you were asked to construct, and you are also, at the end of the day, you are asked to find the length of that arc. So it's possible that you can have multiple topics put together and form a question. This is what's called complex question. So watch out for this. I can also manipulate this much more by asking you to find the area of this. So by extension, I can add mine there. This was your standard question. Now I can ask you to now find the area. So let's say you wanted to find the area of that structure, the area of that shaded portion. Let's say it was something like this according to that. So now this is 120, and you have found that this is 5 centimeter already. So we want to find the area of that portion. So that section has been demarcated for you, so you can find the area is theta over 360 times pi r square. Watch out for that formula. You already have theta as 120. This is 360 times 3.142, and you now have your 5 square. So that by extension, you'll be asked to find the area of that shaded portion. So that shaded portion would have been this part that is shaded. All this part are shaded. So this is P, that's the one, Q, P, D. So this is P, and this is Q. So this is D. So it is this portion I've taken out to there. So you've seen that I have moved from construction, I have moved to measuration as well altogether. So this is a combination of what you're supposed to do. You have a complex situation, and you'll be required to actually solve the vector. Then later you go through the construction, and later you move to the measuration. So that is the end of that question 2009. It's a WASC question private exam.